My guest today is Craig McLuckie. He's the CEO and co-founder of Stacklok and co-creator of Kubernetes. Craig will be sharing his thoughts on how engineering leaders can navigate the shift to an AI-first world. He's going to offer some practical advice on how to rethink where value is created and adapt team structures and adjust processes to integrate generative AI for maximum efficiency. Craig, welcome to the show today.
Thanks for having me on.
Yeah, and I just want to point out, like, I got my career started around the time that Kubernetes was really starting to take off. So it's a real pleasure to be in the same room with somebody who like was pivotal in such a foundational technology. So
No, it was a super
really,
fun journey. It also ages me a little bit. That's when you got
yeah,
your
yeah, no,
got
yeah,
your
yeah.
career going.
Yeah, no, but awesome. So let's just jump into it. So, one of the reasons we wanted to bring you in here to talk today is that you've been talking about this concept of an AI maximalist philosophy. So let's talk about that a little bit and how that sort of differs from like the more gradual or conservative approach to AI adoption. So let's start there. So what is this AI
What
maximalist
does AI
approach?
maximalism mean? Well, I think for me, it's really about shifting the mindset of a team where um, you'll encounter a lot of organizations that'll ask, can we use AI to improve this? And I think changing the narrative is like, why can't we use AI to do this? Sort of
Yeah,
really pushing the envelope. And so for me, the way I describe the intent behind AI maximalism is, we're living in a world where the cost economics of doing business is changing. We really need to find ways to kind of push the envelopes and jump into a world where we start to challenge a lot of our operating assumptions around what works well and what doesn't work well. How value is being created in organizations. And so, yeah, the catchphrase I use for my team is like, let's embrace an AI maximalist approach. And it's really about inverting the question. Can we do this with AI to why can't we do this with AI? Show that it cannot be done with AI first.
yeah, I've actually, as I personally have been adopting AI, I've found a lot of situations where, early on, like hallucinations were a big problem, and they still are today. But I feel like that's, as context windows get bigger, and as the technology improves, like that becomes less of an issue. But particularly early on, when I would encounter an issue where I was trying to solve something with AI and it would fail, taking that sort of approach of like, why can't AI do this? And then actually just asking my model, like whether it's Chat GPT or whatever, like, why are you struggling with this? And like, help me help you unblock this issue. Then suddenly you're getting to more of a productive state where you're actually like starting to unpack the challenge, and you can almost like piece by piece understand a problem of like, why is AI struggling with each individual component of this, and then just solve it piece by piece.
And I think that's a really essential, one of the key learnings I've had has been, I've been in distributed systems for a long time. My first project I worked on was clustering for Windows NT 351. If you want to like really date me, that kind of tells the story of how long I've been working in distributed systems. And one of the observations that I've made about myself is that as I started to approach this technology, I thought I understood it. I thought I was clever. I thought I was smart, right? It's like, well, I've built a few things and some of them have been okay. It's just another distributed systems. It's just another technology asset, but it's not. It is a stochastic system. It's a probabilistic system. The way that it works is it's a natural source of entropy in your environment that enables you to unlock new capabilities,
Yeah.
but it comes with these very specific limitations. And the sort of the thing that really caused me to start trying to invert the way that I was thinking was I just didn't intuitively understand a lot of the properties of this class of systems when I first encountered them. I remember having this vociferous argument with one of my kind of principal researchers about the use of synthetics in training and refinement. And I couldn't get my head around. I'm a kind of information theory geek, and from simple information theory perspective, you add entropy, you start to reduce these things down. The results should get worse, not better. But that's not how it works. And so, I think one of the kind of key observations that I've certainly seen for myself, and I've seen a lot of others kind of embrace, is that the value creation narrative around the use of generative AI systems is somewhat inverted. People tend to approach it with a platform engineering mindset, and that idea that like, well, I understand the system conceptually. I'm going to need a vector database. I'm going to need this. I'm going to need that. I'm going to plug them together. I'll get it basically working. And then I'll just, tune and refine the system until it produces the results that I want, which is how we built things like Kubernetes.
Yeah.
It's just not, it doesn't work.
Yeah.
You got to kind of invert it. You got to figure out what works first. You got to figure out why it works. And then you got to figure out how you can, kind of improve it over time. And it does involve this inversion of thought, which is, I think, is very important.
Yeah, and you mentioned like this natural system of entropy, like, getting back to like my comments on like hallucinations, it's like that both is like kind of like viewed as, I mean, that's primarily viewed as like a failure of an AI system when it like hallucinates, or it like that probabilistic system like goes down a path that is unexpected or is viewed as like being wrong or a failure. But that's actually like the way it's designed fundamentally. Like it's supposed to behave that way because there are many times that it actually does that, and it does it exactly what you want it to do because
Well,
that's
yeah,
what it was intended
it's
to
like,
do.
and there's a lot of papers being published these days that, like, I don't know if you saw the paper a couple of days ago around, hallucinations effectively an artifact of the reward system during training.
Yeah,
You're rewarded to produce a result. You're not rewarded to say, I don't know. So, of course, you're going to do that. But I mean, at the roots of it, the core operating sort of principle here is that you've basically taken a lot of information, you've extracted the semantic meaning of that information and created a set of embeddings. And then you've created a set of attention heads that are, receiving a certain amount of context and then working to collapse down a probability field one token at a time to produce a result. It is stochastic. It is
yeah,
probabilistic. Things are going to change, and attention is everything. Like the Google paper, attention is all you need is great, but it's also finite. And like at some point, self-attention mechanisms do collapse under their own weight. At some point, things will start to hallucinate, and you won't know when until you try,
yeah.
and you won't know how to kind of maintain a system until you do. And I think that's why you really have to make this jump in with both feet and to start to challenge your own assumptions around the use of these technologies.
One of the problems I think a lot of people face is that they apply this probabilistic system into really what is like more of like a deterministic problem set or deterministic problem area. But also, I think a lot of people look for deterministic ways to sort of constrain and control these systems. So do you feel like a push and pull between like the probabilistic nature of this, but with along with like a need for like more deterministic control systems? Like, does that play into your like maximalist like system in some way?
Yeah, I mean, I think it's important to recognize what it is and what it isn't, right? And like, it's interesting. You're not going to know what it is until you try it. So I'll give you two kind of examples of how we embraced an AI maximalist view in our organization. One that succeeded and one that failed spectacularly, right? Just to give you a sense of it, right? So the thing that succeeded spectacularly for us was building our own knowledge management server, right? So basically, what we did was we built a server that would go and capture documentation from Google Drive, would go capture content from GitHub, Discord, all of these things, generated a system that would go process that, create a set of embeddings, put a semantic engine in front of it. You could query it and you could ask it things using, any of these existing systems and would come up with very lucid answers. And, conventional wisdom would say like, hey, I'm an engineering organization. That's a tool I can go buy. Why would I build that tool? Well, the answer is like, it shocked me. It's what we built took about 2 weeks and it's shockingly useful. It's just changed the way that we work. And we
Yeah.
would never have known that unless we'd actually gone and tried to build it. And it was just a fantastic success story for our own, kind of self-actualization on the AI journey. It's not something we can plan to commercialize, but it's just, wow, it's a really cool system. And then we tried to do the same thing with, Prometheus data. We're running Kubernetes clusters, and we're starting to ask questions like, "Hey, loop, pod goes into crash loop back off. Can we use these models to do some initial RCA so that our SREs,
Yeah.
instead of our SREs getting the page, getting some kind of RCA that reduces like TTR, time to recovery, for these systems?" And the answer was no. Actually, we started playing with it. We tried to build these systems. We generated we got some data. We generated a whole bunch of synthetic data. We ran it, and what we discovered is that when we started just presenting raw time series data to these things, they would just collapse the context, the self attention mechanisms, and we were getting far better results by just performing basic Bayesian analysis for looking for correlation between Prometheus streams than we would ever get out of the transformer. And not every organization needs to know that, but like until you actually spend a couple of weeks giving it a go, you just don't know.
Yeah, the root cause analysis has been such a wild one with AI because like and sometimes like I have seen a lot of people give you the advice of like just paste your stack trace analysis into AI and it will tell you the answer. And it's like sometimes it does, just like right off the bat. And it's like, and if it happens the first time, you might think, wow, this is amazing. And
Yeah.
maybe we'll do this all the time. And then the second time you do it, it's like, oh, your Kubernetes cluster has a memory leak. So just allocate more memory and it will be solved,
Yeah,
right? Like it's like,
absolutely.
no, it
And
won't
like, no,
actually.
it's going to crash in 15 minutes.
Yeah, yeah. Yeah, well, instead of 15 minutes, it'll
Yeah.
be 10 minutes or
Yeah,
something.
exactly. So like, it's funny how these things work.
Yeah, yeah. So, so something that we've seen that you've mentioned in the past is, how some of this is impacting, like, team roles, team structures, that type of stuff. So, what are some of the most, like, surprising or, like, counterintuitive changes that you've seen to, like, the roles or the structures of teams, that it or particularly among teams that have successfully integrated AI? Like, how is it impacting a team structure?
Well, I think there's a couple things here that are sort of, and I drew these sort of curves, for folks, and it's something I like to draw, which is, the first thing to recognize is even in an AI maximalist world, where we're doing everything we can, we're using every tool, every trick we can think of to kind of drive our own productivity. When you look at the cost associated with producing great code, we've seen perhaps a 20-30% reduction in the cost to produce great code.
Yeah.
And this is, we're writing the unit tests using these technologies. We're doing everything we can to get there. Turns out the cost to produce bad code is infinitely cheaper, right? Because I can produce bad code
Uh,
like overnight. I can produce bad code, using Cursor to solve anything. And so I think one of the key things is, it is definitely changing the narrative, right? The ability to use, like the distinction between roles, right? Like and the work associated with specific role. Like there's nothing stopping a designer instead of producing Figma, producing a scaffolded prototype that you can click through, right? The class
yeah.
of work product, the way people start to self-identify changes. But then there's also some invariance. Like you can't, bad code takes work to become good code. You can certainly use these tools to sort of shorten that path, but it's going to take time. And the other thing is to say great code does not equal great product. So, in terms of the concrete things, radical improvement in the ability to iterate and produce disposable code,
Yeah.
the need to actually dispose of disposable code, because disposable code can be free like beer or free like a puppy. And if you choose to hold on to it, it's more free like a puppy. It's going to cost you a lot
Yeah.
more to maintain and turn into great code over time. Um, there's obviously, tensions that emerge, with an organization where there's a sort of temptation to vibe code. The natural tension where someone like, what the hell? You just vibe coded a 1,500 line PR. Like, why am I reviewing this for you? This makes no sense. So
Yeah.
definitely some kind of cultural, reinforcement necessary that, you produce the code, you own the work artifact. And so definitely the way that people work and sort of, radically improving that sort of fast turnaround loop and changing the way that we think about disposable code as an asset for that early iteration cycle. And then the rigors associated with actually disposing of the code that's being produced is one thing. The second thing I'd say is kind of back to that knowledge server example. These systems are fantastic at synthesizing and summarizing data. And like you may not get actually, sort of perfect results every time. They'll occasionally miss a document. They may, to your point, there's occasional hallucination if they get into a situation where the sort of self-attention systems become a little bit overwhelmed, or there's just not enough parameterized data to render a great result. But bringing all of that data to teams in a way that they can introduce it into their day-to-day work so that they don't have to context shift, they don't have to context switch to Slack and interrupt another engineer to get an answer to a question is fantastic. Being able to flatten the organization significantly because you don't have to have managers as a primary arbiter of the flow of information and information summary kind of up the management chart because this information is now democratized and it's immediately accessible. I don't need to go to an engineer manager to know what an engineer is doing. I can just ask the knowledge server that, like, hey, what did so-and-so do last week? And it'll give me a pretty decent summary. It won't be perfect, but if I really care, I can go look at their PRs. I can go and actually ask a manager to get in some more details. But it's just creating this running downhill experience from an engineering management perspective because a lot of things that were hard are just suddenly free.
Yeah, and I love that in particular because so much focus when people talk about AI, even still today, which still kind of surprises me, is on generating code. Because that second half of your answer there is very distinctly not about generating code, right? And that potentially being a big impact can improve a developer's life without actually touching anything related to writing code, right? And personally, that is a big area that I've seen, like knowledge and skills acquisition, as a like just a thing that we all have to do as knowledge workers. Like that has been one of the biggest, I think, often overlooked things that AI does that really helps a lot of people.
Yeah.
But I want to touch on the concept of disposable code because you're not the first person that has discussed that concept on our show before. We've actually, Andrew and I, the host here at Dev Interrupted, we have talked about this concept quite a bit in the past. We actually have referred to a lot of what we do internally, both at Dev Interrupted and LinearB, as disposable code because we are in an era now where a marketing team can build their own internal app in an afternoon that doesn't have to serve any purpose outside of their own team or even an individual moment because now you have an AI that can just build it for you. So I'm really curious if you have any sort of like success stories that you can share of where you've seen someone like take a more like disposable approach to code. And even like specifically, like I really like, how you're saying like it's one thing to generate disposable code. It's another thing to know when it's time to get rid of that code and to have like a process for like efficiently and like, effectively getting rid of that code when its time has come to an end.
Yeah, I mean, I think for us, probably the biggest success story around disposable code was, you know, having an engineer vibe code a system, or like having an idea on a Friday, vibe coding over the weekend, showing up with a POC that we could look at and, get a real sort of acute sense of and basically say like, yeah, that's a really good idea. Look, I'll give you an example of this from my previous life, right? Like, when we we're getting Kubernetes going, the whole thing that caused Kubernetes to click in my head was there's this guy, Brennan Burns. He's one of the most creative, amazing engineers I've ever worked with. And like, I was having this conversation with him around like, we were playing with ideas in this area, and like, I was pretty keen on Docker as a container, as a container framework, for like, packaging software.
Yeah.
And I described this thing to him, and he went off and coded it, and he's super fast. You just jam it out there, right? And I came back, and I hadn't really connected the dots until I saw what he built, and I was like, "Holy shit! You just built a personal Borg cell." Like, and it's just like, I was like, "This is it! Like, this is the thing, right?" And it would take someone like Brennan Burns to do that. Like, he was the kind of guy who's just this creative
Yeah.
genius. He would just produce things. Like, you could walk around with this guy, and like, I swear, if a VC just followed him around for 2 weeks, there's 10 fundamental ideas that'll just drop out of his mouth, right? Like, he's just that kind of guy. But his ability to execute quickly and produce prototypes is a superpower, and not
Yeah.
everyone had it. Not everyone has that power.
Yeah.
And like, I've seen this in my own organization time and time again, where people come up with ideas. Like, we built a system we call Toolhive, which is it's something we are like all in on as a company. And that, Toolhive didn't spring into life as a fully formed concept. It was just a great engineer on my teams, having a weekend fling, vibe coding something that we looked at, and it was great. And we've also produced probably 20 other things just like it, which didn't sort of stick the landing. And so I think that sort of early ideation, rapid ideation, has been just wonderful, as an enabler for the organization. I've also seen, having a designer go off and vibe code something makes it much more real. Like, the
Yeah.
ability to actually, touch it and feel it and reason about it is fantastic. Uh, from the marketing side of the house, like, a lot of the content we create, we'll give the devs a week to go off and just vibe code some crazy ideas together. to show how you can use the system to create outcomes. And some of the greatest ideas aren't coming out of actual working prototypes aren't being generated by the developers; they're being generated by other members of the organization. So there's just so many examples where bringing creative energy into the organization that's provable through an artifact you can see, touch, work with, and then if it's great, invest in and turn it into great code. Or if it's not, just throw it away and just don't have to live with it.
Yeah. So do you sense that more of the push is coming from the non-engineering side, or is it more coming from the engineering side? Like, do you feel like the real potential is like non-engineering folks coming in, getting their hands on AI and being like, look at this prototype that I built. I think like maybe it's a marketer, maybe it's a sales rep. They're like, I built this thing. I think I can market it or sell it. Here's the prototype. I need an engineer and a product person to see if maybe we can turn this into reality. Or is it the engineers doing kind of the reverse of that? Or is it a mixture of both? Like,
Well, I
what
think
do you
it's,
sense?
like, I mean, this is an age old story, right? Like, and there's, shadow IT has always been a thing that's existed, for, since time
I
immemorial.
used to manage shadow IT, so
Right.
I know.
And it's like, I remember, like, and if you've ever run an IT organization, like you'll eventually have this moment where the business comes to you and they went ahead, like they weren't happy with you as an IT, kind of provider. And so they secured some budget and then they hired some consultants and they went off and built this crazy janky thing in 2 weeks that they start using. Right. And it gets to a point where, eventually you get called in and they're like, yeah, we're using this now. What are you using it for? Oh, we're using it to, do our XYZ, and it's not working anymore. And I'm like, and then you're like, well, why is this my problem? And it's like, well, you're an IoT person. It's like, and then you look at it and you're like, holy crap, like, what were you thinking? Like, this is never going to scale past a certain point. You've done this, kind of crazy thing. And now you're left living with this thing that someone else owns. So I think there is this very real, problem associated with, kind of sort of weaponized shadow IT, where you're going to start ending up with a lot of systems that are going to be showing up with production implications that are going to become a natural part of a team's lifecycle because they can simply build them and they don't know any better. So there's definitely risks to an IT organization from that perspective, and it does beg the question, like, if the team that you're serving can produce the system in a certain amount of time, if you are not able to kind of embrace a certain amount of agility where you're serving the needs, they will self-service. They will
Yeah,
ultimately absolutely do that. We may get to a point where these technologies get good enough that code is more like an intermediate language than actual code.
yeah,
We may well get to the point where they're actually producing sufficiently robust capabilities that things will work well. But the reality is they're not there yet. Like, we just aren't there yet.
yeah,
The reality is that we don't have reasoning systems. We have systems that are emulating reasoning
yeah,
through planning loops and iterations and other pieces. They can, context is everything, but it's finite. Eventually, the self-attention mechanisms collapse. Things become too complex, and then you left handing, kind of holding the bag for the team.
yeah, yeah. There's a lot of hype around like artificial general intelligence. I think really what we have now, and maybe even for the foreseeable future, is simulated intelligence. It's like something that looks exactly like intelligence most of the time,
Yeah,
and then it doesn't suddenly.
I think the way, and I'll probably get yelled at by AI purists for describing it this way, but I keep coming back to this book by Kanahan, Thinking Fast and Slow.
Okay.
Right. So Kanahan describes these two systems in the brain. The first system is, the sort of system one, which is like the fast thinking system.
Yeah.
And then system two is the sort of reasoning system. And you kind of need both, right? Like, you need to be able to look at, process visual information. That's a chair,
Yeah.
based to, turn visual information into something that has semantic meaning. And the closest analog that we have, in terms of generative AI is it's effectively kind of, like that sort of fast thinking system. It's not a reasoning system. It's emulating reasoning by making snap judgments to generate planning and then running kind of internal iterative cycles.
Yeah.
And the essential thing that's missing is the bridge between system one and system two. Like, when we see a chair, and if our brain says it's a chair, but it's not a chair, like, something will like think us like, is that really a chair?
Yeah.
Is that really a something? And we actually have the ability to catch ourselves. And then we have the linkage where, the work that, the reasoning starts to program the fast thinking systems. Those don't exist. So, I think you're right. it's emulated reasoning. It's not actual reasoning. And because it's emulated reasoning, it'll work within the boundaries of a certain set of operating attributes. But at some point, things do tend to fall over.
A listener out there, their company is just starting their AI journey, or maybe they've, made a little bit of progress along it, but, they're still, struggling along the way, or they're still learning a lot. What's some practical advice that you would give to somebody who's still like sort of early on in that experimentation stage, and they're, maybe not quite at full scale adoption, but trying to get to that phase? Like what is the advice that you would give to someone who's in that stage right now?
I would say that, first of all, you have to recognize that a lot of your intuitions and instincts are going to be wrong. And so there's this learning arc that you have to embark on, which you have to embrace a certain amount of patience with. And I think for me, the learning arc that worked for myself and my organization was, first use the tools just to understand, what the art of the possible is. Then actually attempt to build the tools and optimize the tools. And once you've got to a point where you're successfully feeding yourself with tooling, you then may be positioned to start, building, kind of general products. So like, go buy Cursor license, start using it, use it a lot, figure out where
Yeah.
it falls over, figure out how to make it better, figure out how to connect Cursor to a variety of existing systems using MCP servers. Great. Get to a point where you can say like, well, okay, what would a knowledge server look like? Don't buy it, just build it. Like just throw yourself down the cliff, try it, see what happens.
Yeah.
Um, it's a
I
lot, at the end of the day, it's a lot easier to take a great engineer and get them to that point where they have that intuition, that instinct around what works and doesn't, than it is to take someone who has learned the intuition and instinct around what, like how these things work, and turn them into a great engineer. And you just kind of have to be patient with yourself and your teams and look at it as a path towards understanding through use, then optimization, and then delivering actual, sort of systems. Like there's a lot of work associated with building long-running stateful agentic systems. It eventually will deconstruct into a distributed transaction problem. I promise. Workflow always does. So unless you're willing to kind of work your way into it just over time, you're going to get hurt.
Yeah, you've used the phrase vibe coding a lot, which gets a lot of negative attention, and we've addressed that on this show a lot, so our listeners are very familiar with our take on it. But and you've used a little bit harsher language than I typically use. I think you said throw yourself off a cliff with it, which is I like to say vibe code until the wheels fall off. Like you should do that at least once, just
Uh,
so you see what happens. Like
it's faith-based engineering. Throw yourself off a cliff with a bag of parts and make sure you construct a plane before you hit the
yeah,
ground.
yeah, just so like this is what happens when it all falls apart on you, so
Yeah,
that you're prepared, so that when you're serious about it, like you can protect yourself
yeah.
and be ready
And
for it.
like you gotta like it's a sharp new tool. You gotta treat it with a bit of respect.
Yeah, yeah, exactly.
Like it's like sidle up to it, use it a bit, learn it, understand it. Just chartering a team to go off and like, hey, build this long running
Yeah.
stateful agentic subsystem with reflection patterns and memory and, kind of tool calling and context retrieval and all that. I promise not going to work. You get there eventually, but I promise, like, unless your engineers have actually walked the journey,
Yeah.
you're going to be disappointed.
There's a lot of frustration, and
A
then
lot of
frustration
frustration.
leads to
And you just
negativity,
don't
and
know,
then
like,
yeah,
why is this breaking? I don't understand what's breaking. Well, you just added a new tool. Well, what happened? Well, you just bumped the thing over a threshold where,
yeah,
like, it's not rendering too much context and it just is not performing the same way. Or, like, hey, you just updated a model. You got to realize the prompt and the model and the orchestration pattern are all tightly coupled. These things, like,
yeah,
they cannot be easily decoupled. Like,
right,
behavior is optimized for probabilistic outcome.
yeah,
And until you get your head around that, it's going to be a bit of a bumpy path.
yeah. So, we've talked about how, like, there's efficiency gains around generating quality code, there's efficiency gains around generating bad code. So, but beyond efficiency, like, what do you think are, the biggest benefits that, or even challenges that engineering leaders are going to face as they start to integrate generative AI and agents into their core processes? Particularly if you know of any like unexpected ones that people maybe don't typically see.
Well, I mean, there's the bill at the end of the day. Right.
Well, everything's subsidized by venture capital right now,
Yeah,
so the bill is a lot cheaper than
and like, and a lot of people are like, I speak to a lot of very smart people, and they're like, don't worry about it. Like, like like using sparser matrices and this and that and all these other things are going to, inferencing costs coming down, it'll be fine.
Yeah,
Um, like no, the bill is going to continue to increase. I think the biggest thing I see is as a problem for organizations is this. It's effectively change management in the context of something, right? So it's not like you start to get to a system where you've with care and love and iteration and running kind of running gradient descent for your prompt optimization, all of these things, you produce this relatively optimal system. The problem is that the minute something changes, and it could be like, hey, I'm using a tool call system with MCP, and I'm starting to kind of project tools that are now available. A tool description changed, all
yeah,
bets are off.
yeah,
There's no guarantee that it's going to continue to invoke that tool in the way you want. I layered on 5 more tools in my registry, and it was doing dynamic tool binding. And suddenly, I've layered in 100 tools, and suddenly my context when I start to just present a tool list has been blown up from 10,000 tokens to 150,000 tokens, and all bets are off again, right? So I think the fact that you really need to kind of, it's not enough to just get it working. You also need to understand why it's working and what's going to be introducing entropy and sort of inconsistencies into the system over time is really big. And I think that's been probably one of the more surprising things I've seen is just how things are fine until they're not,
yeah.
and that sometimes surprises people.
Awesome. Well, Craig, I appreciate you very much coming on our show and sharing your
Oh, it's
insights
fun.
with our audience. Yeah. If our audience wants to follow you after the show, where's the best place for them to tune in
Uh,
and keep up with you?
hit me up on LinkedIn if you want to have a conversation, Craig McLuckie, or just look at the toolhive.dev website if you want to learn more about some of the technology that we're working on.
Awesome. And to
Thanks
our
for having me.
listeners, thanks for tuning in today. If you're not subscribed to our Substack, make sure you sign up for that. And thanks for joining us this week.